Today we'll learn about drug tolerance and tachyphylaxis. Let's start with drug tolerance. It is defined as the gradual loss of a response to a drug after repeated administration that requires higher dose of a drug to produce same effect. In drug tolerance, onset is gradual, occurs in days to weeks. It requires higher dose to achieve the same effect. Drug tolerance is reversible, it reverses when the medication is stopped. Now, at this point you should be curious to know how this occurs and what's the mechanisms behind it. The mechanisms are not clearly understood, but it may be due to pharmacokinetic tolerance, pharmacodynamic tolerance, and cross-tolerance. Let's see each of these in detail with examples. Starting with pharmacokinetic tolerance. Pharmacokinetic tolerance is also called as drug disposition tolerance. Chronic use of drug leads to increased drug elimination or drug metabolism. Thereby, decreases the concentration of drug at the site of action. Examples include barbiturates and carbamazepine. These drugs increases drug metabolism due to chronic use and hence decreases the response. On the other hand, amphetamine, it enhances the drug elimination and thereby reduces the response on chronic use. The second possible mechanism by which drug develops tolerance is pharmacodynamic tolerance, also known as cellular tolerance. Chronic use of drug down-regulates and desensitizes the receptor, which ultimately decreases drug action and hence produces the less response. Examples include morphine, barbiturates, nitrates. The third mechanism by which drugs develops tolerance is cross-tolerance. Tolerance to one drug causes tolerance to another with similar mechanism, meaning drugs belonging to same class develops tolerance. Examples, morphine and codeine. Moving on towards next term that is commonly used in pharmacology is tachyphylaxis. Let's first decode the meaning behind this term. Tachy means fast, and phylaxis means protection. Tachyphylaxis is defined as the rapid loss of a response to a drug after repeated or continuous administration over a short time. In tachyphylaxis, the onset is rapid, that is within minutes or hours. Even a higher dose cannot restore the response. It is reversible, the normal response returns when the drug is given again. The mechanisms behind tachyphylaxis includes depletion of neurotransmitter stores, receptor desensitization or internalization, feedback inhibition. Let's learn each one of these in detail and with examples. Depletion of neurotransmitter stores, commonly seen with indirectly acting drugs. Examples, ephedrine and tyramine. They releases catecholamines in body. When these drugs are continuously used, the stores get depleted, and thereby produces no response. Moving on with second mechanism, receptor desensitization or internalization. The receptor stops responding as it is overstimulated due to repeated use of a drug. Examples, nicotinic agonists like nicotine. The third mechanism by which tachyphylaxis occurs is feedback inhibition, wherein overstimulation triggers internal feedback that suppresses response, leads to rapid loss of drug effects. Example, beta agonists like isoprotronol. To summarize all this, tolerance is gradual loss of response on continuous or repeated use of a drug. Tachyphylaxis is rapid loss of response on continuous or repeated use of a drug. With this we've completed this topic. Hope this helps. We'll meet with another topic. That's all for now. Keep mastering, keep learning, only on Mastering Meds.